Most students are not comfortable with completing the square because they've been taught something called the quadratic formula. Once students memorize and know the quadratic formula, I find that they almost exclusively use this technique to find their solutions. I do not care which technique you use to find the roots or the solutions of a quadratic equation. However, if you're told to use completing the square, you must use that technique, that process. If you're not told, if you're told just to find the zeros or solve the equation, then you can use whichever process you're most comfortable with. So again, we have the form ax squared plus bx plus c equals 0. That helps us identify a and b and c in our quadratic formula. So x would have to be the opposite of b. For us, b is -2, plus or minus the square root of b squared minus 4 times a. For us, a is 3, times c. c is -1. Don't forget your positive and negative signs. All over 2 times a. So x must equal a +2 plus or minus the square root of 4 and 12 is 16 all over 6. And the solutions we get using this process better be identical to the solutions that we got using the process on the previous slide. Everything has a factor of 2. So I have 1 plus 2 over 3, which is 1, or 1 minus 2 over 3, which is -1/3. The same solutions we found using the other process. The more and more mathematics you learn, the more it becomes possible to find a solution using different processes. So make sure that you choose a process that is the most obvious, or make sure you choose a process you're comfortable with. But if you're told exactly which process to use, make sure you use that process. Remember, the discriminant tells us something about our roots based on the SIGN sign of what's going on underneath that radical in the quadratic formula. If the value of b squared minus 4ac underneath that radical is positive, you're guaranteed that you're going to have 2 real roots. This is what the graph of those solutions could, this is just one example of what they could look like. Remember, roots are x-intercepts. It's where your function crosses or touches the horizontal axis. If the discriminant equals 0, you will have only one real root. Your graph of your function will touch the horizontal axis only once. So you'll have one real root. It'll just be a repeated root. If the result is negative for the discriminant, your graph of your function will not touch the horizontal axis at all. For us, in calculus, we don't deal with the complex plane or imaginary numbers. We stay right in the set of real numbers. Many of you in Algebra 2 class were probably taught something called synthetic division. I'm going to go old school, and I'm going to use polynomial long division. I dislike synthetic division because I don't believe the student actually understands that they are finding roots of the polynomial and that they are actually simplifying an improper fraction, an improper rational expression, and the result will be a polynomial and a proper rational expression. I believe with long division, students get a much better idea of what's going on in the process than they do with synthetic division. We're at the point in our mathematics career now where it's not just about finding the correct answer. What we're after is a process that we can make sure that all of the pieces and the parts mean something, and we're ensured that we can use all those pieces and parts to actually answer our question. We are dealing with multi-step problems when we start talking about AP Calculus, so I want to make sure you understand the mathematics that's involved. So we know from grade school, when we do division, we take what's on the top, our numerator, and we divide it by everything on the bottom, our denominator. So that's what I have set up here, is a long division problem. It says x plus 3 will divide into the polynomial x squared minus 5x minus 24 how many times? What does that division look like? So here's the process for polynomial long division. We're going to look at the lead terms in the numerator and the denominator. And we're going to ask ourselves, what do I need to multiply this lead term by to get that lead term for the answer? So what do I multiply x by to get x squared? That's x. And that's the process. That's what we're going to do. Every step that we go along the way, that's going to be the question we're going to ask. If I have x here, and I multiply it by this lead term, that gives me x squared. But I also have to multiply it by everything that's out here, because x is attached to 3 with addition. So I need to distribute that term everywhere out here in my denominator. So that's actually what the resultant multiplication will look like. I put parentheses around that result so that when I draw my negative out front, I won't forget to distribute it to all the terms that follow. So I have x squared minus x squared. That results in a 0. Now I have negative 5x minus positive 3x. That results in negative 8x. I don't have it written here, but it pretty much could be plus 0. So negative 24 plus 0 is negative 24. Now I start the process all over again of the lead term compared to the lead term. I ask myself, what do I multiply this by to make it look like that? That's negative 8. I take negative 8 and distribute it all the way through these parentheses. Negative 8x. Negative 8 times positive 3 is negative 24. Parentheses around the result. Put a negative out front. Negative 8 plus 8 is 0. Negative 24 plus 24 is 0. There's no remainder here. So this tells me that the numerator has 2 factors. Here's one factor. There's the other factor. X plus 3 times x minus 8 will be equivalent to x squared minus 5x minus 24. And then I'll copy down the denominator. So there is polynomial long division with no remainder. If I were to graph this function, it would look like a line with slope 1 and a y-intercept of negative 8. But recall, we talked about this before, you would have a hole in the graph at x equal negative 3. When you have the same factor in the numerator that you do in the denominator, it is not a vertical asymptote, it's a hole in the graph. So that finishes up our exponential properties and our Algebra 2 review. come to class next time. We'll work some homework problems.